Hi everyone, welcome to this demo session. My name's John Taylor and I'm from Imperas, and today I want to talk a little bit about instruction set simulators. If you saw Simon's keynote this morning, he's already covered some of the material in here, but I'm going to have a little bit more time to go into some more of the details and explain some of the complexities in a modern ISS and why it might be unfamiliar if you've written simple ISSs in the past. So if we think about what it means to develop an instruction set simulator, why you might be doing it, typically you'll start from an architecture specification such as, the RISC-V ISA. If you're building a chip on the hardware side, you do your RTL development, block testing, you worry about things like PPA. And on the software side, you want your ISS to allow you to do software development, maybe some architectural modeling. And you might use them for verification, where you compare them against each other, check for quality of results. And for the base RISC-V ISA, you've just got 47 instructions. So, how hard can this be, right? Must be easy. But requirements evolve quickly over time, and we see a bunch of things that make this more complex. So to start with, that 47 instructions. Well, if you start using the standard extensions, that quickly becomes tens, if not hundreds. All of those need implementing. Then we've got things like spec churn. We've seen, yes, there's been a lot of work in the last year or two ratifying lots and lots of specifications, but they are continuing to evolve. New extensions are coming along, and you need your model to be adaptable and updatable to deal with that. You might be adding custom extensions, or if you're developing IP, your customers might be adding custom extensions, and it could be custom instructions, it could be custom CSRs, and then there's a whole host of other things you might need to think about as well in terms of using your simulator in a larger system simulation environment. How do you worry about peripherals, interrupts? Can you reuse it in your next project? And so that idea of having a simple ISS that's really quick to develop yourself suddenly becomes much more complicated and much more challenging. And we think the answer is the Imperas as a processor model. So, we've spent a lot of time working on instruction set simulators for many different architectures, and RISC-V is the latest one for us. And we provide an industrial quality model of all of the RISC-V specification. The fact we've got 250 parameters you can configure gives you an indication of just how complex it is. And you can see there we've got support for all the different versions of all of the ratified extensions. So if you're building something and you're trying to get ahead of where the specs are, we can probably work with that as well. And that's a really good starting point, but you can build on that as well. So as well as having that base model as a kind of reference, there are very well documented and very well defined APIs that allow users to extend that and add your own extensions, add your own CSRs without perturbing that base model. So from a verification point of view, you don't have to worry about changing that base model, upsetting anything there, but everything you develop is kept separate, and there's a lot of supporting material to help you with that as you add your customizations to the design. We make our models available in kind of three different ways for RISC-V. The simplest is RISC-V OVP Sim, and that's a free version of the simulator and model available on GitHub. It has support for all of the standard RISC-V envelope ISA, and it's used by the architecture compliance suite and can generate signature dumping for that as well as a golden reference. Then we have an enhanced version of that called RISC-V OVP Sim Plus. That's available from the OVP World website. Again, it's still free even for commercial use. And that adds some additional functionality in terms of tracing and logging. And if you use RISC-V DV for device verification, it can also work as a golden reference model within the RISC-V DV framework. And then we've got our commercial models, and that's similar structure. It's just adding more functionality. It's adding the ability to customize. So if you start with one of those free models and you want to extend, you're not going to have to throw away any work you've done, but you can build on that, and it integrates with our Imperas DV verification environment, and the sort of GUI tools and things around that as well. And the common philosophy is that the models are open source, so you can look at the source code of the model, you can look at how we describe the RISC-V ISA, but we have a proprietary simulator underneath that. I want to talk briefly about a couple of customer successes and some real-world use cases, because I think these are quite interesting. I have another talk in about an hour, co-presenting with NSI TechC, looking at virtual platforms for automotive. But this was a really interesting case because actually they're doing heterogeneous simulation here. So they've got an existing automotive MCU in a different architecture. They're adding some RISC-V accelerators to it, and actually they're adding, I think, 16 RISC-V cores, and they're running a simulation here with all of those running in parallel. And they used it for early stage development of their software stack for an automotive microcontroller doing small scale AI inference. And they're able to use the ISS to build this complex system, simulate it all in parallel very, very fast, so their software was ready ahead of their silicon. We've also done quite a lot of work with Dolphin Design and Open Hardware Group, and the advantage of having this golden reference ISS is you can build it into other things like Imperas DV. You can also use it to generate things like functional coverage, which is also very valuable for verification. And Dolphin they've added about 300 instructions to the base RISC-V ISA for DSP. And we worked with them to help verify that and also generate the functional coverage so they could prove they'd achieved high quality verification of their entire design. There's also a good use case for an ISS with emulation. When it comes to doing verification of CPUs, again, as Simon talked about in his keynote, the number of cycles you need to run, it's just impractical in a RTL environment, so you're going to have to use an emulator. And you can use our model alongside that as a golden reference. You can simulate co-simulate lockstep with your emulated core, and there's support there for things like asynchronous events. If you want to do debug, you want to do interrupt, you can do that and you can achieve high quality verification. But there's another use case as well with emulators where if you're building an SoC and you've already got your core verified, but you want to simulate your SoC faster, you can replace the core with a model and then put the rest of the RTL around that, and you get accelerated output, you get faster simulation to prove the rest of your SoC design. So to try and wrap this up quite quickly, ISS requirements have grown over time from that simple, I just need to run some software, to actually I need a full golden reference model that I can use in a variety of use cases for all sorts of things. And doing that in a scalable, maintainable, productizable way is actually really, really hard. But we've been doing this a long time. We've got a lot of customer success stories, and actually as I say, in bang on an hour's time in the theatre, we'll be doing a co-presented talk with NSI TechC about virtual platforms, and they'll talk in more detail about some of these real-world use cases and see how using a good virtual platform with a good ISS can lead you to success. So that, I'd like to say thank you very much. Our booth is just back over that way, so if you do have any questions, you do want any more follow-up, please feel free to drop by and say hello. We'd love to talk to you in more detail.